You run SSH admin at old web 01, expecting a normal login, and SSH throws the big red wall. Remote host identification has changed. The deployment window was last night. Maybe the VM was rebuilt. Maybe DNS now points somewhere else. Maybe someone is sitting between you and the server. The dangerous move is the one most people make. Delete a line from known hosts just to get work done. Today we slow down and read what SSH is really telling us. A host key is the server's identity key. It is not your login key, and it is not the same as the public key you put in authorized keys. The SSH server has its own private host keys, usually under /etc/ssh, and it proves possession of one during connection setup. Your client stores the matching public key in known hosts. That gives SSH memory. The first time you connect, there is no memory yet, so you make a trust decision. That model is called TOFU, trust on first use. After that, a changed key is not routine noise. It means the identity you remembered is not the identity answering now. Mechanically, the server sends a public host key during the SSH handshake. Your client checks known hosts for the name you used, and usually the IP address too, depending on settings in previous entries. A known host line contains host patterns, a key algorithm such as SSH ed 25519, the public key data, and sometimes a comment. If hash known hosts is enabled, the host names in the file are hashed, so the file does not casually reveal your server list. Non-standard ports are stored as bracketed host and port. When the presented key matches, SSH continues. When it does not match, OpenSSH stops, because continuing would erase the main defense this file provides. Here are the basic tools. H is the host you're investigating. T selects the P type. ED 25519 is the common modern host key type on current OpenSSH systems. K names your user known hosts file. SSH-keygen -F searches known hosts for that host, including hashed entries, and prints what OpenSSH knows. SSH-keyscan asks the network service for its public host key, and with -H, writes hashed host names. The T command appends the result to the file. Important: SSH-keyscan retrieves what the network gives you. It does not prove that key is legitimate. Use it after you have verified the fingerprint some other way. Here is the clean rebuild case. You replace a lab-vm, keep the same hostname, and SSH complains on the next connection. First, confirm the rebuild really happened. Your change ticket, hypervisor console, cloud instance ID, serial console, or configuration management record. Then get the new host key fingerprint from a trusted path, not from the failing SSH prompt. On the server console, run ssh-keygen -l-f against the public host key. Once the fingerprint matches what you expect, remove only the old entry with ssh-keygen -R. Then add the new scanned key and connect again. That is a fix. The biggest mistake is blindly deleting the warning away. That trains you to ignore the one moment SSH is trying to protect you from impersonation. The server-side command on screen prints the fingerprint of the public host key, and you should get that output through an out-of-band channel, console access, a trusted admin, your inventory system, or deployment automation. Do not use strict host key checking no as a lifestyle choice. It weakens the check that known hosts exists to enforce. Strict host key checking except new can help automation add brand new hosts, but it does not validate identity, and it still should not be used to wave through changed keys. Known hosts sits below most of the SSH topics we will build on. Your SSH config host aliases affect what name gets checked. User known hosts file can move the file for automation or for separate environments. Update host keys lets a trusted server teach the client additional host keys after a successful connection, which helps key rotation. DNS SSHFP records can publish fingerprints, especially useful when paired with DNSSEC. At larger scale, OpenSSH host certificates move trust from individual remembered keys to a signing CA. But the foundation stays the same. The client must know whether this server identity is the one it intended to reach. For a 5-minute lab, use your own machine if SSHD is running, or a disposable VM. Do not practice on production names. First, make a backup copy of shale SSH known hosts. Set H to localhost or to your lab VM name. Run ssh-keygen -F to see whether an entry exists. If this is only a lab target, remove it with ssh-keygen -R. Then scan the host key backend and connect. Now open known hosts and notice the hashed host name, the algorithm, and the key material. The point is not memorizing the file format. The point is getting comfortable editing it deliberately. 3 beats to keep. First, the host key is the server's identity, and known hosts is your client's memory of that identity. Second, the first connection is a trust decision, not a formality. Third, a changed key can be a normal rebuild or a serious impersonation signal, so verify out of band before you remove anything. Once verified, use ssh-keygen -R and add the correct key back cleanly. Tomorrow, we keep building SSH from the ground up. New SSH episode daily on this channel, plus the daily ranked CVE brief for administrators who have to defend real systems.